So let's have a brief introduction to the landform classification for Canada and to the online viewer that has been produced for interacting with it and evaluating it. Go to www.isric.org/landforms. This will bring up the viewer that's been built by George de Jesus using Cesium JS, and this is just a brief introduction to the viewer and how the various controls really. So it does, as you'll notice, it takes a little bit of time for the maps to draw to the screen. They are pyramided, but they're still rather large raster maps, and it takes a bit of time to display. So be patient and let the map fully complete displaying before moving on to your next activity. So the first thing we'll do is to zoom in a little bit, just so that we don't have to display for quite as large an area. So I'm using the roller on the mouse to just zoom in a little bit. You can also use this plus and minus over here to zoom in and zoom out. And again, whenever you zoom in or zoom out, you have to wait for a few seconds or several seconds until the screen refreshes and redraws the information at the new resolution that you're looking at it at. And the map that we're looking at here is a classification of Canadian landforms according to the Hammond approach as implemented by DeCau. And again, we're going to have a quick look, and you'll see that it's somewhat relevant and appropriate, but it's also very generalized. Just a quick indication of the controls. We have overlays and we have base reference maps. So right now we're looking at the Hammond as an overlay, so that's this one here, and as a base reference we're looking at Bing road maps. So we could replace the base reference with say the Bing maps with area labels with a little bit of information about the background topography, and as you can see you still have Manitoba, Edmonton, Saskatchewan, some labels showing through. If you want to see the underlaying map more, you basically make the overlay less transparent, and as we make the overlay actually more transparent, the underlying map, which is the Bing label map in this case, becomes more visible. We'll go back here and we'll make our classification map a little bit more visible, and we get an idea of how the classification matches the topography. We can pick one other map here as an underlay map, and we'll pick the hillshade for Canada, produced at 250 meters. And the hillshade will emphasize the relief aspects of the classification. So there we now see the Hammond classification, where blues are level plains and basins, and greens are undulating plains, and the tans are low hills, and the browns are high hills, and low mountains and high mountains. So essentially a fairly simple 8-class classification. We can look at this in flat 2D, as with here, and if we click on any particular color and then consult down in the bottom right hand corner, we'll get an indication of what that color is interpreted as. So this is grid code 110, and it has the Hammond classification name of A1, which I think is probably basins. And here we have the Hammond classification name of C5. Besides looking at it in map view, you can use this inner ring here, where it says drag the outer ring to rotate and drag the inner ring to get a 3D view. I prefer using the control, holding down control and then moving my mouse north-south basically to get a little bit of a view of the classification and the landform in 3D, as you can see here. So we'll get sort of optimum viewing angle, rotate it a little bit, and I always over-rotate. Okay, and then maybe zoom in a little bit. See if we have a little bit more detail, but in essence the Hammond classification generalizes. It's intended to generalize, and you get the big picture from it. And it seems to do a reasonably good job at picking out level planes from undulating planes from low, medium, and high hills, and then low and high mountains. If there's a issue with the Hammond classification, it's that as you zoom in and get to review it at finer and finer scales, it loses some spatial precision in terms of the location of boundaries. And you start to see a little bit of circular rings around classes that are a result of using a circular neighborhood analysis window when doing the classification. So again, we're looking at this at about 1 to a million, I think. And now we'd be about 1 to 500,000. And at 1 to 500,000, the polygons are no longer quite as convincingly related to landform or as easy to interpret, because you start to see that they reflect the generalization of the Hammond classification, and they're not all that spatially precise in terms of how they outline hills or valleys. For instance, this one here is going right through a drainage, an obvious drainage or stream, and overlapping it and putting the drainage in with something called a hill or a toe slope. So that's the Hammond classification, and what we'll do now is just switch to the new Macmillan classification by clicking on this, and get a sense for how the Macmillan classification exactly and explicitly follows drainage sequences and hill slopes. So things that stick up and things that stick down get more or less precisely located. And again, I think in order to get an overview, we'll go from 1 to 500,000 here. We'll just zoom out to 1 to 1 million. I do recommend now, when we're looking now at about 1 to 250,000. So we've zoomed into just about beyond the scale that you would recommend using this at. And as you see, some of the boundaries are no longer maybe in an optimum position, but they are still properly aligned relative to observable major valleys and major ridges. So I'm thinking maybe we'll look at this at 1 to a million, something like that, to get a bigger overview. So when the number at the bottom right goes to 1 to 10 kilometers, and it's about 1 centimeter in size, then you're looking at it at about 1 to a million scale. And as you see, the classification here is picking up your major plains regions in Alberta, your foothills moving into the mountains, and within the mountains in BC, we're getting reasonable detail when we get down into the valleys. We're not just calling it all a valley, but we're picking out the various different elements down in the valleys and classifying them as toe slopes or foot slopes or channel bottoms. Well, that's about it. You know how to log on. You know how to change the view, the display resolution. You know how to pick an overlay in terms of the 2 that are available now, and more will be put up as we are able to, including classifications by other methods like Iwahashi and Pike and Maybeck and Soter. And we'll also put increasingly other backdrop images in here, remote sensing classifications, land use classifications, other imagery that will provide a useful backdrop for reviewing these maps. So in the meantime, I would encourage you to visit the isric.org/landforms site, view the maps, compare how the various classifications that we've been able to apply for all of Canada at 250 meters, how they perform in terms of both recognizing general regions of plains and hills and mountains, and also in terms of being spatially detailed and spatially explicit, as I would hope is evident in this map. Anyway, thanks so much. Visit the site, have a look, let us know what you think.